Hello everybody, my name's Josh. I was a computer science examiner for a really long time. I also run a tutoring business and I was a teacher of computer science and head of computer science in UK based schools. This series is all to do with giving you as little as possible to remember while still being able to access the top grades. Today's topic is going to be on hexadecimal. This is relevant for all specifications. These are the spec points we're going to have a look at. These are the knowledge-based questions that we're going to look at. So the first question that could potentially come up, I'd write this on a flashcard. Why do humans use hexadecimal over binary? One hex digit is the same as 4 binary digits, so less likely to make a mistake when typing them in. Mark number 1. Easier for humans to read. As long as you've got that point there, which is all about one hex digit is the same as 4 binary digits, you will be able to access the top, all of those marks on there. Now, the next one is uses of hexadecimal. So state 2 uses. IP addresses, MAC addresses. These are 2 examples where hexadecimal is used. Okay, people. We are now going to be looking at how to convert between hexadecimal digits and binary numbers and vice versa. So hex digits are just a different number system. It's actually base 16, so it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it goes A, B, C, D, E, F. And I'm going to very quickly show you how to convert between these different number systems. So if I needed to, the first thing, let's say we need to convert 3A into binary. The first thing that I'm going to do is I'm going to write down A is equal to 10. B is equal to 11. C is equal to 12. D is equal to 13. E is equal to 14. F is equal to 15. You are definitely going to get some kind of hexadecimal question on your paper. We don't know what it is, but I'm going to show you a nice easy way of converting these. So we can see on here that we've got 3A. So step 1 is I write down A, B, C, D, E, F like that. I'm writing the numbers that correspond to these. As an examiner, I always see students make mistakes because they guess what C is and they think it's 13, or they get 11 and they think that that's A. Just write it down. It's going to take you 10 more seconds and you're going to guarantee that you're going to be able to get the marks on this one. So we write that down, then we're going to cut it down the middle. We then change any letters into numbers, so that's 10. And then what I'm going to do is I'm going to treat these as 2 separate binary nibbles, which they are 4 bits each. So put 1, 2, 4, 8. Separate nibble. 1, 2, 4, 8. Okay, then just convert them into their numbers. So 3 is going to be 0, 0, 1, 1, because 2 and 1 equals 3. A, 10, so 1, 0, 1, 0. Okay, now that is how you convert from hexadecimal into binary. To convert from the other way around, so binary to hex, let's have a look at how we do that. We take this number 1, 1, 0, 0, 0, 1, 0, 1. So there's this 1 down here. Cut it down the middle. Put 1, 2, 4, 8. 1, 2, 4, 8. Now I just convert them into their own separate numbers. So 12, 5. And then what I'm going to do is I look, are any numbers 10 or higher? In this case, I've got 1, which is 12. I have a look at my little grid on the side. 12 is C, so I'm going to put C. And then that's going to stay the same. 5. So the answer to this one is C5. The last thing that we need to do is we need to convert between hex and denary and hex. This is one of the more challenging parts of the course. And what I've tried to do is simplify this, going with what we want to do, which is giving you as little as possible to remember. So let me show you how to do it with one of the ones that we were doing earlier. So let's say the question is convert 3A into denary. Now, you're probably thinking, why have I left this part up here? What we have to do is it's the same steps. So you go from 3A into binary to start with, even though we're converting it into denary. And I'll show you in a second why. So we convert that, and I've got my numbers there. I then, once I've finished converting it into binary, I'm going to cross this out, and I'm going to put the numbers in. So 16, 32, just like in our normal binary conversions. I could put in 64 and 128 there, but they're 0, so it's just a waste of time. And then all I have to do here is then I just add up all of the ones that have got ones underneath them. So 32 plus 16 is 48. Add the 8, 56, add the 2, 58. So this number here, so 3a in denary is 58. And I've used binary as the middle step. So what I have to do is I go from hex to binary, and then I go from binary to denary. And if I needed to go the other way, I would convert it into a binary number, cross out the 32, 16, 128, and 64, and I'd put 8, 4, 2, and 1, and then I'd convert it back into hexadecimal. And that's the method which I personally think is so much easier for you to do. It gives you much less to remember. You get so much better at converting between binary and all of the other ones, and it just means that you just have to remember one method as opposed to remembering loads of different ones like hex to denary and denary to hex. So that is the method I would use, people. Now let me show you how to do it with a couple of the other ones, just so that you get an idea. So put this over here. Now we've got E3 into denary. So step 1, what we are going to do, cut it down the middle, any numbers that we need to convert, or any letters that we need to convert into numbers. So that's going to be 14. And then what we're going to do is just treat them as 2 separate nibbles. So 1, 2, 4, 8. 1, 2, 4, 8. Convert them into their separate numbers. So 14 is 8 plus 4 plus 2, 0. And then 3 is 0, 0, 1, 1. Cross this out, put 16, 32, 64, 128. And then we're going to go through the process of adding these up. So we're going to do 128 plus 64. So that's going to give us 2, carry the 1, 9, 1. So 192 to start with. Then we're going to add on 32 onto there. So 32. 4, 2, carry the 1, 2. So we've got 224. Add on so we've got a 3 for the last part. So 224 plus 3, and that's going to give us 227. So E3 in denary is 227. So again, I'll just do one more just so that you can see an example of how it's all done. So if we go 97 into hex, so we'll start with the denary value now, so 97, and then we do 128, 64, gonna have to move this along in a sec, 32, 16, 8, 4, 2, 1. Try and move that out a little bit so you can see it a bit better, okay? Then we ask the question, starting from the furthest left-hand side, does 128, is it equal to or less than it? And then 97, it's not, so we're going to put 0 there. 64, 1, take that away. 3, 3, so that leaves us with 33. 32, 1, so that's just going to take that away from there. And that leaves us with 1, doesn't it? So that makes it quite nice and easy. So 0, 0, 0, 0, 1. And then what we're going to do is split this down the middle. So we've got 4 bits each side. So I cut that down there. And then I'm going to cross these out, replace that with 1, 2, 4, 8. And then I simply just have to convert it now. So that is going to be 6 on that side and 1 on this side. So the number 97 in hex is going to be 61.